Welcome to the Real Python Podcast. This is episode 218. Are you interested in learning robotics with Python? Can physical electronics-based projects grow a child's interest in coding? This week on the show, we speak with author Marwan Alsabbagh about his book, Build Your Own Robot, using Python, CRICKIT, and Raspberry Pi. Marwan discusses his two conference talks about building electronics projects with his children. He provides advice on equipment and techniques to make learning Python engaging. We explore his robotics project and the literal balancing act of designing a robot around the Raspberry Pi. Marwan shares his successes and disappointments while working to incorporate computer vision, joystick controls, and voice commands. This episode is sponsored by Mailtrap, an email delivery platform that developers love. Try for free at mailtrap.io. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hi, Marwan. Thanks for coming on the show.
Oh, it's a pleasure.
Yeah, so I'm excited to talk about not only your book, but talk about getting into working with electronics in Python. It sounds like you started where a lot of people are starting today, I feel like, with CircuitPython. And I've had a few people on. You might have looked through the list of guests I've had to talk about CircuitPython and my excitement about it. Something I haven't talked about is the robot part of it, which I think is going to be fun for us to kind of dig into. Maybe we can start there. How'd you get started on this journey?
Well, it's very much like you said. It started with CircuitPython and microcontrollers, and then it developed like future projects into expanding into robotics. But basically at home with my kids, and just wanting to do something fun with them, on weekends. And I grew up I just loved computers growing up. I mean, I grew up with like an MS-DOS machine, coding on Quick Basic and making little video games. And so I had that passion when I was a kid, and it's a very different world now. And when I wanted to do kind of like a project that's like a educational project, but also just have fun, with it. One of the things that really attracted me about like microcontrollers and CircuitPython is that it's physical, because kids these days are just used to being in front of a computer all the time, whether it's an iPad or an iPhone, whatever. And so I wanted to take them away from a screen. And, microcontroller, that's the beauty of it, right? I mean, you can get the Circuit Playground for like $25 and then they'll just have that in their hand. And they make it really fun, Adafruit that make this, one of these microcontrollers that runs MicroPython or CircuitPython.
Yeah.
You can write your name on it, whatever. But what's cool is it's all contained there. You don't need to assemble anything. It also like comes out of the box with enough for you to do fun projects. So compared to like a Raspberry Pi is much more powerful computationally. I mean, you run Linux on it, basically, a whole OS.
Yeah.
But when you turn it on, it's just a computer. You need to connect a monitor and a keyboard and mouse, something like that. With Circuit Playground, what's neat is it has all these LEDs on it that have RGB or whatever. And then, it also has touch sensors, push buttons, speakers. And so you have enough that you can start playing around and say, hey, let's take some inputs. Let's write a basic program that reacts to when you press these buttons, it makes these sounds or does these lights. And so that made it kind of more interactive. And then Adafruit on their website have a lot of great ideas and inspiration. And so that's what turned into the first project, was just like putting it into a snow globe and doing that.
Yeah, you did a talk about it, the Pi, I don't even know how to pronounce it. Is it Londinium 2018? Is that?
Yeah, it's some weird old name for London.
Okay.
I had to look it up and be like, what does that mean? Then, an old English or something. I was like, okay. So,
Ye old Londinium. That's pretty cool. But yeah, you have a YouTube video. You kind of go through all of it, and you have some fun stuff in there where you're playing around. And I can tell you're having a lot of fun with it, with at least one of your daughters. It seems like your other daughter is somewhat interested, but not as much as the one. She seemed like super digging it. And
yeah, it's exactly that, spot on. I mean, like, and that's the funny thing. Like, so my eldest daughter, when she got old enough, I also tried to do these projects with her, but I really try and let the kids take the lead. And she's much more interested in making slime and doing karate and I don't know what, and she just wasn't into like coding or building stuff as much. And then with our second kid, she just loved like building stuff, like crafts and wood and whatever. And so one of the funny
video of her with the saw and the drill.
I tried to combine her crafts and wood making with it, and it worked out pretty well on both projects. We combined woodwork with it, which is fun. You get away from the machine, you build something with your hands, which is challenging sometimes to teach computing with carpentry. You know what I mean? But it's a nice, fun, hands-on mix. But.
Yeah, and that's neat. The snow globe is literally a perfect fit for that Circuit Playground or Playground Express.
Yeah,
is that what it's called? Playground Express.
Yeah, it's called the Circuit Playground Express. I think they had an older one ages ago, called Classic, whatever. But now it's just all the Express.
Yeah, that's such a cool product. I bought one myself, and I agree with you. The idea that you don't know what direction things are going to go, not only for yourself, but especially with a child, like what is going to be the thing that piques their interest. And this thing has such a great smattering of sensors, lights, inputs, outputs, all that sort of stuff on it that you can kind of go in all these different directions, that you could kind of almost leave it open like a catalog on the Adafruit site. What does interest you? Which is cool. And so I really dig that about the project. I think one of the things that I like a lot about it also is the idea that you can attach stuff to it without having to get into soldering.
Yeah.
Were there other things that you had to keep in mind with a kid, like outside of like you don't want to have to get into soldering?
Well, it was one of those things. I mean, she was 6 at the time, and so like just to keep her interest, I had to do it over a period of time because, and I knew that because I'd already hung out and done stuff with her before. I knew her well enough with my own kid, but like, so mentally I pieced it out, and I said, look, today we're going to do the woodwork, and then next weekend we can go and pick whatever doll, because she put like a doll inside the snow globe. And that was really crazy. She liked it because she got to choose the doll, and it just kind of barely fits in. And so that was like fun, but it's kind of like piecing it out for her. And then I think the other thing is just experimenting, trying different things. So I really liked the idea of trying to teach her some concepts of physics, but without calling it physics, so that she doesn't be like, this is boring. So we learned about like light and sound. Light in terms of the different frequencies of, sound in terms of different frequencies of sound.
Yeah.
Because it has a little Python function where you can play a tone at a certain hertz. So I told her, look, it's just a number that tells you if it's high pitched or low pitched. And then I told her about how dogs have a different hearing range than we do. And that excited her because I was like, they can do stuff we can. And I was like, yeah, and there's stuff they can hear and you can play that. Sound if you know the hertz, whatever. So that was neat in terms of sound. And then light, we used the RGB to understand that like what we see is composed of red, green, and blue, basically. And then how could you make your own color by choosing those and the color table a little bit, and then doing the math behind it, but very, very like basic stuff. Like if you do red and green, what do you get? Because I knew, I didn't want to ask too much or whatever, but it worked out well.
That was great. I could tell just from maybe like a little cheat sheet and exercise for her to kind of go through and try out the different colors, converting them. I thought that was great. I had seen a demonstration at one of the PyCons, and I'm trying to remember who did it, but she had done a similar thing with the microscope. And zoomed in on the NeoPixel and showed that, it's just 3 elements, and you can see them there, and you can see as you create the different colors which are lighting up. And I could right away, even though I wasn't there, I could see that a kid would be like, wow, that's amazing. So your daughter probably just really dug it. And then like, how do we combine them? And if I'm not that close up, I'm further away, like what does it actually look like? And that's neat. And
it's funny like how some of that stuff develops. I mean, like with looking at the lights zoomed in with the microscope, that was just something I bought for fun. And we used to look at raspberries and all these crazy stuff like a carpet fiber. It looks really crazy when you zoom in. And I didn't know that you could do like see the individual RGB, but I tried it and it worked. And I was like, this is so cool. Like that she could write the code, press enter and see it live.
Yeah.
Like the individual. So a lot of the stuff was almost like accidental discovery.
Nice.
And the thing about like the paper color table, like I'm such a deep believer, and sometimes as much as possible, just step away from like computers and keyboards and learn computing with like paper and pen.
Yeah.
And that's like using a little creativity, you know, like, but I did it with teaching her about RGB. And then we did it with the robotic librarian, which is like a project we did the following year. And that one was with the Raspberry Pi. And that's what was basically the precursor to the book, because it moves around and it pushes stuff. But when I did that, we had to make a user interface to control the robot through the phone. And I really didn't want to just sit in front of a computer and do drag and drop. So I told her, this is what we're going to do. We're going to get a pen and paper, and you're just going to draw on a piece of paper, however you like.
Okay.
You know, and she just got her crayon. She's like, can I use any colors I want? Sharpies, whatever. Yeah, have a blast. So she drew the interface on a piece of paper. And for her, this was shocking. She's like, Ricky, but how do we get this on a computer? And so I told her, we'll just use the scanner that I have in my room. And she's like, what is that? And she'd only seen like, it's a printer scanner. She'd only seen printer functionality. So I put it on the paper, I scan it. And she's like, that's the most incredible thing I've ever seen. I was, what do you mean? Is this like 30-year-old like scanner technology?
Yeah.
Your phone can take a picture. And she's like, I've never seen that in my life. And it's so funny because sometimes there's stuff that feels old and boring. But to her, she's like, do you know how many drawings I want to digitize? You know, I have like all this artwork that I want to scan. And I never even thought. And then she's like, when I do it on my phone, it doesn't come out the same way. But so we put it, and she's like, it looks perfect or whatever. And then I just did an overlay of the buttons or whatever.
Nice.
But she really liked interacting with computers using like crafts and pen and woodwork, whatever. Because that's what she enjoys, you know, instead of like sitting in front of a computer.
Yeah. I've had a few conversations about teaching kids. One that was Alsabbagh came on, and we were talking to this academic about the one laptop per child program. And she was talking about this whole charismatic thing that people get into about they want to teach the way they were taught, or kids should be inspired the way that they were, like you were, like you had this older, simpler computer and you were putting in BASIC and so forth, and you were excited to type in the code and so forth. But kids today, like you said, they start with a computer in their hands. And so like what is going to be interesting to them, and the fact that she gets away from computers, which is great, and draws on paper, and the idea of like converting it in. So were there other things that helped in this process of, or this challenge, if you will, of teaching them Python? Like, is it like a speed, like how fast you introduce it, or what were some of the other challenges you found in teaching that?
Well, one of the things that worked really well, surprisingly, was the REPL.
Yeah.
Like right when I showed her the REPL, and so this is especially like in Circuit Playground, like we connected it because through the USB connection, you can have a live REPL on your computer and then issue direct commands on it.
Yeah.
So I showed it to her and I said, you just type this text and it'll do this. And she immediately got it, and it's very intuitive. And I think
that's nice.
REPL interfaces make a lot of sense. And she even described, she's like, oh, it's like I'm talking to it. I'm telling it, do this. And then it does it, you know?
We're having a conversation. Yeah.
And, you know, sometimes like when you look at like GUI interactions, they're not so intuitive human-wise if you think of it. Like the idea of like a mouse and a pointer and then grabbing and then clicking it. There's just like going on. And even the metaphor of calling it a window, right?
Yeah.
Like usually you look out a window. You don't take physical windows and move them around, right? You know what I mean? So,
right. Yeah.
So it's really stretching the metaphor. But when you're in a command prompt or in a REPL and you say something in a response, it's a very natural thing. And then we went into that. Now, she was 6 at the time, so she can't type long commands.
Yeah.
So again, you know, the REPL saved the day because of the history. So she'd like write one command.
The up and down.
Like go red or green. And she'd press up and down, enter up and down. And she loved that because she's like, it's got everything evidence. So
she's ready for shortcuts.
It's so funny. But sometimes at work when I'm in the terminal or whatever, and I love like, you know, the command prompt in the terminal. Some of the younger crowd who didn't grow up on DOS or whatever like that, they're like, dude, use a mouse, use a GUI, right? And
Right.
and I'm like, but it's so powerful if you and intuitive if you give it a chance. You know what I mean?
Yeah.
So it was cool to see that even like 1960s or 70s, like tech or interfaces still, can work. So.
Yeah. I thought it was funny. You mentioned that she was having trouble with the sort of extra characters that are not
Yeah.
part of the keyboard there, that she's like this parentheses thing and brackets or whatever.
Yeah.
But once she got the result, she's like, oh, okay, that's fine. And it seemed like that it kind of opened up for her.
Yeah.
Was that across the board using these kind of new symbols and stuff like that?
Yeah. I mean, like one thing that I did very early on is like I took the Adafruit CRICKIT library or sorry, the Adafruit library to deal with Circuit Playground, and I wrapped it in this just little module.
Okay.
That when you import it as I think T or R, one character, so that she would type less. She could just write r.angle or r.light. I made all these shorter versions of what she wanted, like r.angle, so that she doesn't have to type as much. And then I told her, don't worry what r dot means. Just think of, I'm saying angle be this, angle be that.
Yeah.
Just very simple stuff like that. And I think part of it is like having empathy with. It's very funny. So like I built tons of systems for many people, and so over time I really saw the value of empathy and empathizing with your user and not making assumptions about what they're using. So it's kind of like I tried to make an interface or an API for her as an end user, that would take her needs into kind of account. So
yeah.
But yeah.
This episode is sponsored by Mailtrap, an email delivery platform that developers love. An email sending solution with industry-best analytics, SMTP, and email API, along with SDKs for major programming languages and 24/7 human support. Try it out for free at mailtrap.io. That's mailtrap.io. You mentioned some of the advantages of working with Circuit Playground already. What were some of the other sort of projects and things that you decided to do? Like you were playing around with several of them. You played with sound.
Yeah.
That one, the snow globe intruder alert system.
Yeah.
Did it start as just the lighting part of it, and then eventually you decided, oh, we could also do this thing where we play with the sound that she was playing with earlier?
Yeah.
Is that kind of how that went?
So what happened, and that was actually, so I have something in mind usually, but then there's so much hardware constraints, right? Like the Circuit Playground. I mean, it's not running Linux. It's not on the network. You can't connect an app. It doesn't have Wi-Fi. I mean, they have afterwards, I think they made a version that has Bluetooth that you can try and do an app with. But I'm like, what I was trying to do was do a 2-player game or something to interact with her sister, because, she always looks up to her older sister.
Yeah.
She doesn't want to just sit in a room and like make lights go. You know what I mean? So I was like, hey, why don't we make something that could become a game, that you could play with, your older sister, Serena. And so that's how it turned out to be.
Okay.
It has these touch sensors that you can attach the conductive thread, it feels just like thread, but it conducts electricity. And then by doing that, anywhere you touch across this thread, it will, I call the touch sensor sound alarm. And so that's the whole idea, is that I could make it a game. Like you could go and put it, and then you could catch someone trying to walk into your room or whatever, like a burglar alarm or whatever.
Right.
But then they like setting it up, because what's cool about it is that thread is so small and thin that when you put it on the carpet, no one can see it.
Right.
So people would just be walking around and hearing burp, 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 and like, what's going on? And they'd giggle in the corner or whatever.
Right.
And so it's kind of like a fun 2-player physical project that they could carry with them. And that's one of the things I think is important in all these projects I did, is to not make them as much as possible tethered to something, like just to have a battery and then take them.
Yes.
And that can be challenging, because they're used to, kids, especially with a phone, everything is portable.
Right.
But both the Circuit Playground and Raspberry Pi, they don't come out of the box with like a battery. You have to go and add all of that and put an enclosure or whatever. And so we did that as part of the enclosure that we put in.
Yeah, I think that's really kind of a crucial element, like about programming in general. And I think especially for a kid, what have I been up to for the last 2 hours? And I want
Yeah.
to share it with the older sister and kind
Exactly.
of show it
Yeah.
off and stuff like that. And you as a programmer learning this stuff is the same thing. It's like to drag your parents down if you were a kid learning programming and say, okay, sit in the chair behind me. I'm going to show you something on this computer.
Yeah.
And like just that whole idea, but like to carry it to them, to have it on your phone,
Yeah.
to be, you know, like I'm into photography, I'm into music and so forth. And the phone just opened up that stuff.
Yeah.
Like I can share my photography now with you. I can share my music with you. I can share whatever I'm working on. I got into movie making for a little while, and that was just such an amazing ability to do that. You know, I could have an iPad with an entire portfolio. Like I think she might be thinking about that about her art.
Yeah.
You know, in a way, like the scanning it and so forth.
Yeah.
So I think that's such a big element of it. And the portability, yes, then you got to think about, okay, well, how do I get the batteries and power this thing? I had this conversation with Todd Kurt about these electronic projects we were building for making music stuff.
Yeah.
And we just started talking about, well, there was a time in the 2010s where every conference you went to, you got some kind of weird USB power bank that was kind of useless for charging your phone, but amazing for this purpose.
Yeah.
You could plug it into the USB port and it would be enough to power these kinds of things. In your case, you got the specific one that has like the proper connector to plug in the circuit playground, and then it has the AA batteries in it, which is or AAA. I can't remember.
Yeah.
Well, we could probably talk about it more, but like the robot project, you would have to power probably pretty dramatically different, and maybe that's a whole kit then at that point.
Yeah, and that was funny. So the circuit playground the power for it was very simple because it doesn't need that much power, and you're powering one board. There's only one board. What's really funny and was eye-opening to me when I tried to work with robotics, and I just wanted to make something move, you know what I mean? Like, like we're just sitting at our computers and we can completely control what's displayed on a screen and sound that comes out. But it's so cool to just be able to have your software walk around, you know, and like drive around and interact with the real world.
Right.
So the way that the hardware that I chose, and I think you ultimately just have to resort to a lot of this, is the power requirements of the computer are different than the motors in terms of voltages and I don't know, there's all sorts of stuff it has to handle. So, one of the most straightforward ways to do it is you get a Raspberry Pi and then you put on some sort of hat. So these add-on boards.
Yeah.
So the one that I chose is this, it's called Adafruit CRICKIT hat. And once you put that, it handles the power supply to the different motors.
Okay.
And what's funny is what it needs is so demanding that it needs its own power supply. So
so you're powering the Raspberry Pi and then the CRICKIT hat that sits on it, like it's connecting it, needs its own way of routing a larger amount of power to go to all the motors and such. Yeah.
Exactly.
Okay.
So I had to feed power to the both of them. And then, all these other things come out. And I think part of it is just sometimes working with something that you don't have a background in. That's what made me interested in it, because I knew Python really well.
Yeah.
But I have no background in electronics, robots, soldering, nothing. But I was like, let me try and see what happens. And I tried and it worked out. But like one of the things that kept failing, that just drove me up the wall until I figured it out, was I'd have code, I'd run it, and sometimes it would work and sometimes it wouldn't work. And it's just so simple. Like I was like, there's nothing wrong with my program. It's only like 3 lines of code or 2 lines of code. Like I isolated it. And then I figured out that the power supply was just low.
Oh.
And you know what happens when we're working on computers?
That's an unusual thing to debug.
Yeah, because we take it for granted, but like on computers, you can see visually your power supply, right? It's like terms of it. And then all the OSs warn you and say, oh, and then they just shut down, right? They won't let you but this thing is so low level. Some parts of the CPU were working, other parts weren't, and he's just happy. So he's like, yeah, USB's working, the REPL's working, Python's there, but I can't get enough. And part of it is that like you have the Raspberry Pi, which has a CPU, but then that hat has its own little firmware and microcontroller.
Yeah.
And I just saw it on the discussion forum when I asked the question, of course, check your power supply. And, for people who work in it, it's like obvious, but so I'd always make sure I have a good power supply.
Yeah.
And I tried to put that stuff in the book, because I realized, like, for a lot of people who've been working with this, they just take it for granted. But I thought,
right,
as I'm learning this, let me make note of it so that Python people that are first time like working with this, I put as much as possible all these tips. Watch out for this. Watch out for that.
Yeah. So I guess maybe we could talk the timeline after kind of working with Circuit Playground, and you had done the talk, and then is it a year later that you did this other talk?
Yeah. So I did talk for Snow Globe, and then a year later I did this robotic librarian.
Yeah.
And that was basically the foundation for what became the book. Actually, when the publisher approached me, they're really cool. They'd just seen my first book, and they wanted to do a book with me. And initially, they were talking about MicroPython, because that's what the first book was about, or CircuitPython. But then I said, I did that. How about we do something new? And so I said, robots are really cool. I did this talk on a robot. I'd like to do something different. But part of it was selfish reasons to learn something new and do something new. And then I kind of put myself into like a corner where there was enough in that talk to explore and write a book about it. But I wanted to make things more difficult for myself. So I added these challenges and I committed to them kind of in the proposal. And then I had to go through a crazy process of almost little R&D really quick to see is all of this stuff viable, because the robotic librarian, it had all these things that were almost like cheating. So basically it's just this robot that drives back and forward and it pushes books off of a bookshelf. But the way it figures out, and you can choose any book on the bookshelf and it will go to that book and push it. The books are at fixed positions, and I just fine tune like how much time the motor moves to move to each position.
Oh, okay.
So there's if you're going to ask someone to reproduce that, it's such a headache, because depending on the power supply, depending on the distance, like it's all like fine tuning. And so that annoyed me too. Inherently, the other thing about it was I did a lot of woodwork, so I wouldn't have to code as much.
Okay.
So what I did is I made this whole wooden frame and then and then it's just stuck in the track and it's moving, right? But I didn't want that whoever's buying this book has to go out and buy wood and saw and have a workshop, right? So I said, how could I have the book go navigate to the robot navigate to different objects without requiring a saw and a hammer and wood? So that's why I added like the camera and QR codes and computer vision. But, it's nice when you don't add something for the sake of it. Like instead of saying, hey, let me just do computer vision for the heck of it. Like when you're trying to solve for a problem, like how do I remove the constraint of woodwork and make the robot smart enough that it could just detect objects automatically?
Right.
It also made it nicer because you can have as many objects as you want, as far as the track as you want, and you can distance them as much as you want. It's automatic basically. But,
and then you're teaching these fundamentals of, using a camera, vision, QR codes. Like you're kind of introducing all these additional topics that kind of build on top of each other, that somebody can take that and go, okay, well, what if I have this thing do minimal amounts of self-driving, like obstacle avoiding and sort of path finding and stuff like that. You can kind of see where that all goes. And this is me just looking through your book and kind of getting an idea of it. I think your daughter probably really loved the camera stuff. Because I see her in all the photos kind of like waving and doing stuff. And I could tell that she's like a very visual person, which is kind of cool to see.
Yeah, I mean, they've kind of put that requirement on me now, because in the first book, I had a lot of kids' projects in it, and they were included in the photos of it. And so when I was writing the second book, they were like, Bob, but we have to be in the book. And I was like, it's more for adults now, and then they're like, we have to be. So, when I did the facial recognition, like there's one project that was neat. It was like saying, okay, so the robot that's moving around and pushing objects, at the end, you're telling it what to do. And I really wanted to make a robotic system that was automatically responding to stimulus in the environment. And so that's where I saw one of these common projects where you do face tracking and then you put a servo motor on the camera. And basically, wherever you move your head, it's tracking you, which, feels really exciting, especially if you paint a face on it with a smiley, whatever like that. It's basically almost human, like how it's following around. So when I did that, I was like, this is great. This is a great opportunity to just put their faces in the book by they're the faces that get tracked or whatever. So now it's like a tradition to include their photos however I can into the books. But yeah.
That's funny. Were they, again, kind of going on the idea of building up a kid's Python skills, a child learning this sort of stuff? Was there any friction moving into robotic stuff, or was that exciting to them right away?
I think they liked it, but it was always like trying to make it fun. Actually, once they got really, really angry at me, and they went to their mom and complained and said, "Baba hurt us." But so what happened was, I made the premise of the robotics librarian be that my youngest daughter, she's too small to reach the top shelf. So I said, okay, let's pretend we have all these books on the top shelf that she wants, and then she clicks and it grabs the book. But what I did is the robot is sitting behind the books, so you can't see where it's driving. And so I put it into this mode where it randomly shoots books out, and it throws it really fast. And so I told her, lie down in front of the bookshelf, and these books will just be flinging around, and I'll film you as this happens. And I didn't think enough about safety. So when I did this, these books were hitting her, right? And one of them hit her head, and she's 7, and she went, "That hurt." And then I was like, you're right. That was my bad. And so I said, we're going to do it again, but you're going to have a little pillow. And she's like, but this isn't going to protect my whole body. And I was like, yeah, well, it's a challenge. You have to deflect the books that are falling up the top.
It's a challenge.
And so it turned into a game. And I think, if I just sat down and I said, look, this is a servo motor, this is the physical components in it, she'd just glaze over and be like, this is boring.
Right.
But then I turned into this crazy game of throwing books around and her dodging them and having a laugh with her sister, that she's even forgetting that there are robots behind it,
Yeah.
The other thing that ended up being fun and the book content and doing it with her is, it was a balancing act where sometimes the publisher would say, okay, look, you need to think, okay, what's the real world applications of what this person's learning, right? And no one's going to make something to push books, right? So some of the real applications of this stuff is like a warehouse robot that can go around. This is a common thing, and then drive around, find QR codes and package and retrieve it. But if I did that with my kids, it's so boring, even maybe to the readers. So instead I said, okay, let's make a snack pusher robot. And they gave an opportunity of saying, hey, you want a lollipop, or you want, some candy or whatever like that. And just making it more fun. But in the end, you're like, this is actually kind of universal. I could do this to get snacks, or I could do it for a warehouse. And that
right.
kind of,
or do chores for you or things like that.
Yeah,
right?
exactly. Yeah.
But, okay. Yeah, that's cool. I feel like that's a big challenge in so many levels. You're trying to make it engaging because it seems to be a family project.
Yeah.
You were talking about very early on this idea of graduating from the circuit playground into something like the Raspberry Pi and it being a full-on computer. And one of the things you mentioned in your previous talk was just, it's a computer. It has to boot up and wait and so forth. And so was that a stumbling block when you got to the robotic stuff, or was that eventually okay? You were, you can kind of get past it.
Yeah. I mean, I think I'm a stickler for wanting stuff to a fast interaction cycle of working with whatever I'm working on. So, and I'm always going and doing crazy elaborate things to make my development cycle faster, to the point where some of my coworkers are like, that's crazy what you did. Why would anyone do that? And I was like, because it's so slow to restart or reboot or do whatever. You know what I mean?
Right.
And so that's why I love the Circuit Playground initially, because the Python code runs directly on the microcontroller. And it's kind of ironic and amusing that the microcontroller is just a really weak CPU and RAM, and that, it has a faster start cycle than the Raspberry Pi, because the Raspberry Pi is before I can get to your Python code, I have to boot a full-blown Linux OS,
Right. And make sure everything's there and connected and working.
And I don't know if I would have done all those more involved projects if I hadn't had that earlier fun and success at the Circuit Playground. Because, sometimes you're putting little time in. So I think the initial successes is what made you want to take on more challenging things. And the main thing is I was just hitting the limits of what you could do with Playground Space, in terms of I wanted networking, I wanted to interact with joysticks, I wanted to interact with apps, I wanted all that kind of stuff. So I said, I need Linux and all the computer vision stuff.
Yeah, you need a computer.
Yeah, exactly.
Yeah, that is one of the things that's really great about Circuit Playground, or actually most of these smaller CircuitPython devices, is that you plug them into the USB port and they look like a thumb drive, and the code's right there. And as far as the code running, it's just a file, which is so amazing and very, it's an easy step from the REPL.
Yeah.
Saying, okay, all those steps that you just did, we can put them all together in a list together, if you will. Not a Python list, but an actual script, if you will, and it can just walk through all those things and it'll just run it. And I feel like that process is really nice. What was the development process then as you shifted from this sort of simplified version of that? Were you still able to do things with a REPL with the Raspberry Pi? Were you attaching a monitor to it as you were learning how to program with it?
Yeah, I mean, the Raspberry Pi I'd worked with ages ago, but it was like one of those things that years ago everyone was talking about. Was inexpensive, and I was like, let me try it out.
Yeah.
So I bought it, installed Linux, and I was like, now what do I do with it? And then I just shelved it away. So
sure.
And at work, I'm really comfortable doing with Linux servers, and for years now, my main desktop is Linux. So I was really comfortable with the whole environment. So SSHing and the rest of it. But I think there's a bunch of stuff that was a learning curve for me, and it was new because I think that part of the Challenger issue is because it's an ARM processor. And I didn't even think of it until I started seeing some of these challenges. So there's like one bit that annoyed me initially, but what can you do? And you can't have everything be perfect. Usually when you pip install stuff on your computer, it takes a few seconds or a minute. But there's one package that takes like 60 to 70 minutes to pip install. I think it's the computer vision.
Yeah.
OpenCV.
Yeah.
Because it has NumPy in it. Because it's like, I think it has to compile it on the ARM chip and everything. And it's because people don't have that stuff prepared in real files. But you can never have a perfect environment. And for me, I just kept coming back to it because I was like, look, there's these fundamentals that I really wanted to be there. Almost in any book I write is, I don't want it to be something that 2 years from now is out of date, or 5 years, because things change so much. And Raspberry Pi is really like this platform that's been around for so long and will continue to be around for a long time.
Are we on the 5?
Yeah. I think they
recently
did
last
the
year
5
or whatever.
now,
Yeah, okay.
Which I haven't checked out in much detail. It came out after the book, after I set the hardware requirements of the book. The other thing is like combining Raspberry Pi with Linux and Python. And I believe in the idea of building on the shoulders of giants, that, I've invested so much time in learning Linux years ago, and it's just been great because so much of what I learned 15, 20 years ago still works. But all this stuff I learned, in Windows 95 and then NT, and then I don't know what, it just becomes obsolete. That's, I think, the great thing about it. It's inexpensive, so many great guides, so many places you can buy it from, and then runs Linux and Python. And so everything in the book, as much as possible. Well, no, I mean, in case it's all open source and easy to install and free, whatever. So, and I tried to pick libraries that have been around for ages and I sense will be around for years and aren't going to be like just gone in a few years because they're out of fashion or whatever.
This week, I want to shine a spotlight on another Real Python video course. It digs into a topic that I think is really important while learning Python and can be a useful tool to explore how your code is operating. It's titled Python Debugging with PDB. The course is based on a Real Python article by Nathan Jennings, and in the video course, instructor Austin Sapalia shows you how to perform the most common debugging tasks using PDB, including setting breakpoints, stepping through your code, viewing stack traces, creating watch lists, and much more. I think it's a worthy investment of your time to learn how to use this powerful troubleshooting tool and learn how it can improve your code and speed up your efficiency. And as an additional resource, you'll get a printable PDB command reference. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. I mean, maybe we could talk a little bit about the hardware that you decided on. This is a little bit bigger investment as far as like getting into this sort of stuff.
Yeah.
I was actually kind of surprised. I thought the hardware, motors and the chassis and stuff would be more expensive than it was, but it's less expensive than the Raspberry Pi itself, I would say.
Yeah.
But do you want to talk about the just kind of like, what's the hardware that people need to kind of get into it?
Yeah. So it's really fascinating, the whole thing of like DCs and servo motors. So I'll just kind of briefly talk about them, because for me, they're all new topics, like, what a robot's made of. And I was surprised just that the building blocks can be so simple and be so powerful. So you have these two main types of motors. One's a DC motor and servo motor. And DC motor is just a really basic dumb motor. And if you've ever seen like a remote control car, basically the wheels are attached to a DC motor, and you say forward, it goes forward, you say backward, and you can control the speed, but you can't tell it move to this exact location. So DC motors are a great solution for wheels, basically. And then servo motors essentially have a DC motor inside, but then they have a sensor that tells it how far it's moved along.
Okay. Sort of steps that you can kind of adjust to.
Yeah.
Okay.
Yeah. And then the servo, it's basically to come and say, move this arm 10 degrees or 40 degrees or 90 degrees this way or backward. And so those two together, you can do so much. And so it was really important for me to introduce both, use both, and do something useful in it. Because I think like over 90% of what you would ever want to do is just involving those two motors.
Okay.
And so like the end project is the motor moving back and forward on this track using the DC motors attached to the wheels. And then it has this arm that pushes off, snacks off the table, and it uses the servo motor to go and throw objects off a table or a surface or whatever.
Okay.
But yeah.
I know that when you purchase these things, I wonder, because we didn't talk about it yet, but you live in Bahrain.
Yeah.
Is your family there with you in Bahrain?
Yeah.
Okay.
Yeah.
So I wonder about getting equipment. Like I don't know the reach of my audience entirely. I know that I got people all over the world because Python's all over the world. And so I wonder about getting equipment sometimes. Like I know the UK literally has like Raspberry Pi stores, which has never really quite happened in the US, I don't think.
Yeah.
Here we have like Adafruit that's in New York, and I've definitely ordered stuff from them, and I've gone to some other electronics shops. But was that difficult for you to get any of the pieces and parts that you needed?
So that was a really important consideration for me, because and I was torn a little bit about the decisions and everything, and I had to be really. I ended up actually buying tons of stuff. I had an almost R&D phase where I tried so much stuff, because I didn't want to put the reader in a position where I chose some stuff that I was able to get as easy for me, but then 3 years from now it won't be.
Yeah.
And there was so much hardware involved, but I didn't want to back down from what really excited me about the book. So one thing is I wanted to make sure that the stuff I got, so that's what's good about Adafruit products and Raspberry Pi products, is they have suppliers all around the world.
Okay.
And so I made sure, and it's in one of the appendixes, the purchasing guide, that it has these links so that wherever you are in the world, you can find some local stores, or they'll do like international shipping. And same thing with Adafruit, they have like resellers, around the world, which is not the case for some other products. There are like some products that I found that were really good, but they only ship in the US, and there's a way for me to get it. I mean, they have these forwarding PO box solutions, but you have to pay extra, and it's not clear what the charge will be. And so I went for that. One thing that surprised me, that I had so many iterations and I lost a lot of money on this, was joysticks. Like, because
I wondered about
I just
that.
thought joysticks are old technology. It's got to be really simple to just buy any like PlayStation or Xbox compatible joystick. It's like easy. I mean, like, especially I don't need a PS5 or PS4, like even an old PS3 compatible one. And so what's easy to get is the original Sony or Xbox ones.
Yeah.
But they're expensive, And I kind of say, look, I'm using these because many people have a gaming console at home. But what about for the people who don't, right?
Right.
And then, so So I ended up finding all these like no-name brand types of ones and just trying to see on Amazon who has good stars. And I just kept facing this issue where I'd get it and I wouldn't know if it would work on Linux. And I have to wait for it to be shipped from the US to Bahrain. And it would work on a PlayStation, but it just wouldn't work as a normal USB thing because they only implemented the bare minimum. They didn't make it like a generic, joystick thing. But those are some of the hardware. But yeah.
I noticed that a lot about. I'm really into video games, and so I had a problem with that with the PC with certain joysticks of like, I think it was like the 360 or whatever. You had to have like a special USB thing to speak Bluetooth. The current ones all seem to do it, which is nice. But you're right; they're like $50 or $60 US to add that onto something where that's maybe twice the price of the motors that you're spending is exactly, a pretty big investment to put on top of it. Yeah, so maybe we can kind of go through the build up to the project, the kinds of things that people will do as they work through the book. You start off with, you need to be familiar with some of the basic hardware stack, the Raspberry Pi itself, the CRICKIT sits on top of it, and then the DC motors attached to it. Mm-hmm. So you're kind of doing raw basic assembly at the beginning.
Yeah.
Were there other things in that process that I'm missing?
Yeah. So exactly like you said, I mean, you had the Raspberry Pi and that has your CPU and your RAM and your disk, whatever. And then this little CRICKIT hat board, you just plug it on top and it handles all the stuff with the motors. I spent a lot of time and effort and one of the dependencies in how to assemble it all because, you get some kits. This is also something I considered, like Lego Mindstorms, for example, was an option where when you get Lego Mindstorms, everything's coming from Lego and everything's going to plug in fine, but it's, proprietary closed platform. So you can't go do pip install and have all that kind of fun and, reuse that on the software side. And that was kind of the challenge because the Raspberry Pi and the 84 CRICKIT will plug in together fine, but the chassis kit has nothing to do with that. It's like separate chassis kit. And so it doesn't fit perfectly. Like I had to be a little creative and find ways to fit it. And then the USB battery power bank is a completely separate thing that also doesn't come with it. And I had to think of where to put that in.
Right.
And so I had all these iterations and versions.
And that's got weight too, right? You got to think about how it balances. Yeah.
Yeah, because it's eating a lot of power, the motors and the rest of it. They need, you don't want to use something small and then you just keep running out of power, That was also something that after I figured it out seemed so obvious, but without the background I didn't know. Because initially I had the batteries on the top and then it would just keep falling over. I would drive forward and then with momentum, it would tip over. And then I was like, oh yeah, because it's top heavy, right? And then when I started reading more guides, it says, of course you keep the batteries, which are the heaviest component at the bottom. And then I was like, oh, I mean, I never thought of it, but I guess. And so there's a lot of stuff where you just do whatever. And then when it fails, you're like, oh, that's why everyone puts the battery on the bottom or whatever. But I liked learning that.
Low center of gravity. Yeah, that's pretty cool to learn. Yeah.
And I like sharing that, in the book just to be like, be aware. And then also the wheels are funny because it's 3 wheels and the front wheel is just this metal ball that doesn't do anything.
Yeah, it's like a ball bearing kind of thing.
Like a caster ball. Yeah, ball bearing, exactly. And then the 2 back wheels are, each one's connected to a DC motor, which is just this really genius design because it means you don't need a steering column or all that stuff that you take for granted in the car.
Right.
Because, the wheels that drive the power, each one's attached to one DC. So if you want to go straight, turn both DCs on. If you want to go backwards, turn both. If you want to go right, you turn. And it's just so insanely simple.
Yeah.
And they're like, this is cool. But when I first did it, I had the same balance issue.
It really made me think about video games and stuff. I don't know if you remember playing the tank game Battlezone, I think it was called, where it had 2 joysticks and one controlled the right tread and controlled the left tread.
Yeah.
That's totally what this is, right? As far as what the stuff that you're setting up.
Exactly. Yeah.
You were saying that you were trying to control it through a variety of ways. You were creating like a joystick type of control, which makes sense. A lot of those controllers have 2 sticks.
Yeah.
You looked at potentially, you were saying you wanted to have a way to control it with your daughter, like I guess, and that's one of the chapters where you're creating like
Yeah.
a user interface for the like a phone.
Yeah.
What kind of went into that?
So I think a lot of this stuff is robot projects that I looked at, or even I tried. Like I'll tell you about the joystick because it's funny. Like the joystick. So I spent all these years trying to do a talk at a Python conference, and I would keep submitting proposals, and they would always be rejected, all of them. And I had no idea why, because I wasn't getting any feedback, like do this or do that, whatever, like that.
Right.
And so I have this almost zoo of failed talk proposals. And one of the failed ones was a robot project. And it was trying to do like the Fukushima robot of like that you have a robot and you control it remotely. You know what I mean? Like if you're in a nuclear reactor somewhere far where you can't go, where it's hazardous,
right.
then you need these robots to go in. And it came about because I saw that you can, with Pygame, this Python library for gaming, that you could interact with joysticks easily. So I abused Pygame and connected it, through a HTTP connection to another server that was controlling the robotic arm. But I liked it so much that years later, when I had to do this book, I said it'd be cool if I could do that in this book too. But if I could do it even better this time, like instead of abusing a gaming library like Pygame, because it's set up to have a GUI, to go and directly connect it. And that was something that it's really nice, like when you try and do something you don't know if it's possible. It'd be scary, but I really wanted to see, could I like go and interface with it directly? And I found some libraries, but in the end, I discovered the raw joystick events that Linux provides. You can find a way to read them from Python directly.
Okay.
And I've never done anything like that before, but the documentation was really good. I found some good examples, and then the code worked and didn't end up being very long or complicated. And so it was this kind of like side quest that ended up doing something really useful and beneficial, because you don't need the whole Pygame library. And there's a complication where Pygame has its own event loop.
Yeah.
And the robot also has its own event loop, because when you tell it to move, it's like moving the motor and then it's waiting for the next kind. It's like synchronous. So there's all this complication. And I really thought, I know how to solve this. I do this all the time at work. I just do a bunch of threads and do interprocess communication, but I don't want to go down all of that craziness.
Yeah, it gets pretty advanced if you're getting into threading. Yeah.
So I found like that way to simplify it and make it more accessible, and it worked out there.
So that's reading the Bluetooth signal directly. So you're kind of looking at that, if you will, serial stream of data coming in, which I think you could then use for, as you're learning this, there's so many pins on a Raspberry Pi that could be accepting other types of sensors, and you would do similar stuff. Was that kind of how you felt that would work out?
Yeah. I mean, like one of the things I tried to do as well is create like a software architecture and a hardware architecture that I introduced like early in the book, like the first or second chapter. And then in it, I come and I say, look, there's all these abstractions. So one example is, when you're using the app, you can connect to the Raspberry Pi through Ethernet, or you connect to it with Wi-Fi.
Yeah.
With the joystick, you can use USB or you can use Bluetooth. And Linux takes care of all of it for you. You don't have to worry about it. And so that's cool that you can, but just because you can do something, do you really want to? And then that's what was going to open up the next thing. And then, well, it turns out that it's good to use Ethernet and it's good to use Wi-Fi, and each have their pros and cons. It's one thing to just say that, but I also go through piecing together the tools to profile the performance of calls over Ethernet and calls over Wi-Fi. So in Ethernet, since it's a wired connection as expected, like you get, lower latency, better performance and everything. But then you're stuck with the wire, right? Attached to the robot.
Yeah.
And Wi-Fi, you're untethered, you can drive around on your robot. And so I kind of go and show, you can write your program where it doesn't mind which one you use, and then you can just see what's your application like. Do you have like strict performance requirements? As is the case with the joystick, because I set it up where the joystick doesn't even need to be attached or paired to the robot. Like you could, which is the kind of Fukushima example where the operator, is sitting, hundreds of kilometers away.
Yeah. Very drone like with a camera.
Joystick. Right? Yeah, exactly. Yeah. So it's neat kind of using those components that I felt quite confident would work in Linux. I used it up, but I had to test it on Raspberry Pi with the robot and everything, and it worked out. Yeah.
Is there a certain level of experience that you feel people need to have to get into this book?
Yeah, I mean, my like the expected audience is a Python developer, and I really wanted to set it up where you don't have to have any background in electronics or robotics or soldering to approach it. But if you've never programmed in Python before, I think you need to first learn Python and then come to it.
Okay.
With that said, I think beginner to intermediate Python programming is fine, and I worked hard to make the examples really simple and not needing like crazy, I don't know, meta classes or something nuts like that is not so accessible to a beginner or intermediate programmer.
And pretty much all of the components that you're suggesting throughout all of this all use sort of jumper style connectors. They don't require soldering at all.
Yeah, exactly. Yeah.
Okay. I was wondering, we've probably hit a few of these already, but what were some of the concepts that you were really excited about sharing in the book?
A bunch of stuff. Like one, just sharing about DC servo motors, working with joysticks, TCP/IP. Like TCP/IP in the sense that it's there, it serves us, and it's just plumbing that we don't want to think of. And then I come and say, okay, so we want to move our joystick and we want the robot to move immediately.
Right.
And very early on, when I just didn't do any network performance profiling, whatever, like I'd move the joystick and there was a lag, and I hated that. And I didn't have that issue with the app, because when you're in an app and you press a touchscreen button and there's a lag, you don't feel it, you don't care. But there are certain like hardware or end user applications, they're so time sensitive. So, when you move your mouse, when you type on a screen, in a word processor, it's really annoying if there's a lag between typing a word and writing. But other stuff, like clicking on a link on a website, it takes seconds and people accept it or whatever. And so I kind of showed that, okay, if you find yourself that you're trying to make a real-time application and they're exciting, they're interesting, and here's some of the ones in the book, then, how can you go and do profiling? So, I dive into gathering all this kind of samples of network responses and HTTP responses, and then dive a bit into how to generate statistics of the, max, min, median, and what are those needs and what are the numbers you care about, and then presenting those findings, for the Ethernet and Wi-Fi in a kind of practical context of the book, or whatever. So a lot of times there's all this stuff that at work, I picked up over the years that are really useful, a set of tools in my toolbox. And some of the challenges I faced in the book meant I had to pull out those tools.
Yeah.
And it's always nice to have a reason to show the tool instead of showing the tool for the sake of it. You know what I mean?
Yeah, exactly. Yeah, I have this perfect point where like, oh, I can use this and I'm so familiar with it, and now I have a way to explain it.
Yeah.
And now you're actually getting to play with it in hardware, which is really cool.
Yeah.
Do you think Python's a good language for explaining robotics?
Yeah, completely. I think, something that's important is the APIs and whatever that are involved in it. So it's just such an expressive language. And I think the Adafruit library that the code is built on that controls the DC and servo motors, it's just written in a really, really nice way. So
good.
And it's intuitive, and that pairs nicely with Python. Like you can say servo.angle equals 90. And you'd think that would make the server go 90 degrees, and it does. And that's nice, readable code instead of, I don't know, some low level like C and stuff like that. That you just have to do so much before you get to the actual work that you want to do. And I think it's amazing that you can use Python on a microcontroller, because earlier when I was using Python, I always assumed there's a trade-off that if you want to use something fun like Python, you could never run on a microcontroller. And when MicroPython came out, I was like, this is genius. How did they do this? Like, everyone tells you Python, fine, it's easy to use, but assembly's faster. And I'm like, yeah, but who wants to write a machine code, right? So,
right. It's going to take you longer to write it than to, do the application.
Yeah, exactly. Yeah.
Yeah. What's the name of your first book?
MicroPython Cookbook. So it's like a ton of recipes. I think it's like, sorry. The first book's called MicroPython Cookbook, and it's like 110 different cookbook recipes or whatever. So these little snippets, these little projects that you could do with microcontrollers, and it's kind of set up on that standard like cookbook style instead of like trying to make one big complicated project, just little snippets that could take you in many different directions. But
yeah, I mean, I think most people that are into tinkering need the germs of ideas to then glue them together. Again, kind of going back to Lego. It's like you've seen this idea and then you can kind of build on top of it. One of the questions I thought would be interesting is, what are projects that you tried that really didn't work out?
Yeah, I mean, like for me, the stuff that failed, one thing in this book that I really wanted to put in initially was speech recognition.
Yeah.
And it's so funny because, I don't know, computer vision and seeing QR codes in the real world feels computationally much more complicated than speech recognition, because speech recognition has been around for ages, it's old, but it was just really difficult to get a well-maintained open source library that would still be around 10 years from now.
Yeah.
And I got one working on the Raspberry Pi, but then, when I tried to update to a newer version, it just didn't work. And I was like, whoa, I don't want to have this issue for the reader. And what I found is something like speech recognition, if you use an online API, it's really easy. Like, any of these, AWS or whatnot, speech recognition things. But I'm really, really deep believer in, like, if possible and however you can, do everything locally.
Yeah.
Because then you can just tinker and figure out how it works. Like, if you're just calling an online web service, you have no idea what's behind it. But what I love about, like, like, for example, it has facial recognition in the robot, and that's using machine learning to do it. So I cover it just in a practical level. But if you want, you can get deeper and see, well, how do I train it? How do I do that? Oh, can I, make it do stuff beyond that? So I just love that. That's the beauty of open source, is it's not behind some black box. But
yeah, totally. Do you feel like we hit most of the things that you wanted to talk about with the book?
I could talk about it for ages. I just love doing it. You know what I mean? But the stuff that I thought was really fun and everything, we covered. And I'm really glad that that we didn't just talk about the book.
Yeah.
Because it didn't just appear. Like, it has like a backstory, and that's one thing. And I really appreciate that you somehow detected or noticed my passion as, like, just teaching and getting kids engaged with computers and everything.
Yeah. I think that's the programming is so solo so often, and to, like, share it with somebody else and figure out if they'd be interested in it.
Yeah.
And, it's kind of seeing what your kids are interested in. I haven't had that experience, but I have been a teacher, and I love I think any teacher, like, the light bulb moments of watching somebody like get it is just so cool.
Yeah.
And finding out what they're excited about and just sharing excitement and being around younger people. It's just like, it just fills your batteries, with, like, excitement to try to go and do other stuff. And it sounds like you've had a history of that, which is great.
Yeah.
So I have these questions I like to ask everybody when they come on the show. And the first one is, what's something that you're excited about that's happening in the world of Python?
A few things. One thing that I can't wait to happen more and more is running Python in the web browser.
Yeah.
Like, there's a lot of these projects like Wasm, whatever like that. Yeah. And that's just great, because, like, I always have the browser, I'm always working with it. And that's so awesome that, you can just have your program just run, locally on the person's computer. And so it's just getting better and better. So it's just going to open more opportunities and doors. I think that's pretty cool. HTMX, I love that. It's so cool, because it's, for me, bringing the joy back. Like, I started doing web development in the late 90s, and it's so fun back then. And, just all these really heavy framings like Angular, and you keep having to learn new stuff. So I like that. And
and the churn of all of that is a lot.
Exactly. Yeah. So that's the stuff I'm excited about. But
yeah, cool. I'm going to guess this is a fairly easy one for you to think about, but what's something that you want to learn next?
Two things. One, I want to read more and write more. I've had this practice of recently in the past year of, like, reading, and then all this note taking by hand and then retaking my notes and reading them. And it's just really helped me soak into some knowledge and wonderful books. So it's been a great process. I'm going to keep doing that. And I really want to learn how to walk on my hands. So,
okay. Yeah.
So I want to first learn how to do a handstand. Can't do that yet, and then then I found some online courses and whatnot, and I thought it'd just be a fun challenge to do with my daughter because she's pretty good at it. She does gymnastics, and so we can do it together, basically. But yeah.
It's easier talking about centers of gravity. Yeah. What's the best way that people can follow the work that you do online?
The best way is on GitHub, because any new talks or books or whatever, I always just put them on GitHub on the projects, whatever. That's where people can see, I guess, the latest books or conferences or talks I do. But yeah.
Cool. Yeah, we'll include links not only for the book, but for the talks that you've done. Thanks so much for coming on the show. It was really great to talk to you.
Yeah, it was my pleasure. Thanks for having me. It was great.
And don't forget, this episode was brought to you by Mailtrap, an email delivery platform that developers love. Try it out for free at mailtrap.io. I want to thank Marwan Alsabbagh for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.